Hello children, how are you all? Yes, I hope so you are doing good. Please do not forget to subscribe my channel, that is Ignite Math ARP. Yes, in the today's class we are going to discuss about a very important topic, that is Remainder and Factor Theorem, which belong to class 10 ICSE. In this chapter we are going to also discuss about how many questions are going to come from this chapter, for how many marks, how the marks allotment is done in the board exam, what kind of questions can be expected in the board exam. Right, so let me start with the statement of Remainder theorem. The remainder theorem states that any polynomial f of x is divided by any other polynomial x minus a, then the remainder is f of a. Let me explain and now with a simple example by the numbers before we go to the algebraic expression. Suppose, for example, if you are going to divide 32 by 6, this is a normal division what you learned in your lower classes. So you are going to divide 32 by 6. So 6 5s are 30. So here I am going to get remainder as 2. So this is what we call it as remainder. So in this theorem we are going to deal with the algebraic expressions. They are nothing but the polynomials, right? So to make it more simple, I'll just take an example over here. Let me take a polynomial f of x. So now f of x is equal to x square minus 5x plus 8. This is the polynomial which acts like a dividend. So this polynomial going to be divided by another polynomial p of x, which is nothing but x minus 2. Right. So here in this example 32 is called as a dividend, and this 6 is called as divisor, and this 5 is called as a quotient, and the left out one is called as a remainder. So here we are going to find out when the polynomial f of x is divided by another polynomial p of x, what is the remainder, right? So I just find out the remainder by applying remainder theorem. So by remainder theorem, pay attention children, by remainder theorem, the remainder is equal to f of a. See, look at this, f of a, in the sense our a over here is 2. Why it is 2? The divisor is supposed to be equated to 0, then x is equal to 2. So this value of x to be substituted over here. Right. So now to find out f of 2, wherever x is there in f of x, I will substitute that x by 2. So it is going to be 2 square minus 5 into 2 plus of 8. So that is nothing but 4 minus 10 plus 8. So that is nothing but 4 plus 8 is 12. 12 minus 10 is 2. So this 2 is the remainder. This is how I am using remainder theorem to find out the remainder. How to verify that? It is not necessary for you to verify each and every sum. Since it is just a first question, I am just going to verify this one by the long division method. So now I will take the dividend x square minus 5x plus 8 going to be divided by the divisor, that is x minus 2. So keep in mind children, whenever you are performing long division method, make sure that the powers of dividend as well as the divisor, either they should be in the ascending order or in the descending order. Now I am going to divide this f of x by the another polynomial p of x. To perform this division, I'll take the first term of the dividend, divide it by the first term of the divisor. I am going to get it as x, which is going to be the first term of the quotient. Then this first term of the quotient to be multiplied with both the term of the divisor. X into x is x square, x into minus 2 is minus 2x, right? So I am supposed to change the sign over here, plus sign over here, these two get cancelled. Here I am going to get it as minus 3x, and this 8 to be taken down. So when I take this 8 down, again repeat the same process. Now first term of the dividend to be divided by the first term of the divisor, that is going to be minus 3, which is going to be the next term of the quotient. Minus 3 into x is minus 3x, minus 3 into minus 2 is plus 6 I am going to get. So I am supposed to change the sign over here. Again After changing the sign, these two will get cancelled. Plus 8 minus 6 is 2. That is our remainder. See, you can cross check, children. The remainder whatever I have obtained by the remainder theorem and the remainder whatever I have obtained by the long division method, they both are same. But the thing is, in the remainder theorem, we never get to know what is the quotient, right? So we get to know the quotient in the long division method, obviously, but in the remainder theorem, we never get to know what is the quotient, right? So the next part of the remainder theorem is nothing but the factor theorem. The factor theorem states that any polynomial f of x is divided by any other polynomial x minus a, then the remainder is f of a. If f of a is equal to 0, then x minus a is factor of f of x. It's very simple, children. This extended version of a remainder theorem. Now I'll take one more example with a number over here. So this time I'll just take 30, which is going to be divided by 6. So 6 5s are 30. So I'm going to get remainder as 0. Since the remainder is 0, I can say this 6 is a factor of 30. So means what? If I am getting remainder as 0, that is the meaning over here. F of a is equal to 0. In the sense, if remainder is 0, then only I can say divisor is nothing but the factor of dividend. Clear, right? To demonstrate that, I'll just take one more example over here. Let me take f of x is equal to x square minus 5x plus 6 to be divided by the other polynomial g of x is equal to x minus 2. I'm going to check whether g of x is a factor of f of x or not, right? As I told you earlier, the divisor to be equated to 0, then x is equal to 2. So here I'm going to find out a remainder, right, by remainder theorem. Pay attention, children. So by remainder theorem, so what is my remainder over here? Remainder is equal to f of 2. So now I'll find out f of 2, that is 2 square minus 5 into 2 plus 6. In the sense, wherever x is there in f of x, I'm going to replace it by 2. So here I'm going to get it as 4 minus 10 plus 6, that it is equal to 0. See here, if you observe carefully, I am getting a remainder as 0. So since the remainder is 0, so I can say by factor theorem, since remainder is 0, by factor theorem I can say g of x is factor of f of x. If I have not got the remainder as 0 over here, I would not have told g of x is a factor of f of x. So I can say g of x is factor of f of x only if I am getting remainder as 0. Keep that in mind, right? So let me take one more example here, which has appeared in 2023 March examination for 4 marks. Such a simple question, children, such a simple question, it was asked for 4 marks. Please understand, analyze the question before you start solving it. Little bit of patience is required. All right. So find the value of a if x minus a is a factor of the polynomial. So they have given you the polynomial over here. They have given you the polynomial. So the given polynomial is f of x is equal to 3x cube plus of x square minus of ax minus 81. This is nothing but the polynomial what they have given. This is nothing but our dividend, I can say. Find the value of a if x minus a is a factor. They have only mentioned it is a factor. I'm not going to check whether it is a factor or not. Okay, they have only given x minus a is a factor. So what is the factor over here? Factor is a x minus a. So the factor to be equated to 0, x minus a equal to 0, x equal to a. So since x minus a is a factor, what should be the remainder? Remainder should be 0. So now since you can just write down, since x minus a is a factor of given polynomial f of x, right? So that implies by factor theorem. So by factor theorem, I can say the remainder is supposed to be 0. Okay, remainder is supposed to be 0. Clear, children? So how do I find out remainder? So I use remainder theorem to find out remainder. So now if I find out f of a, that is going to be the remainder. Since it is a factor, remainder is going to be 0. Right. So wherever x is there, I am going to replace that x by a over here. So it is a 3 into a cube plus of a square minus of a into a minus of 81 is equal to 0. In this polynomial, wherever x is there, I am replacing it by a. So here I am going to get it as 3a cube plus of a square minus of a square minus of 81 is equal to 0. So here plus a square minus a square will get cancelled. Then I am left with 3a cube minus 81 is equal to 0. That is nothing but 3a cube is equal to 81. A cube is equal to 81 divided by 3, that is nothing but 27. So means what, children? A cube is equal to 27. How do I find out a here? So a is equal to cube root of 27. So that is nothing but a is equal to 3. See, you are asked to find out the value of a. I have found out the value of a over here, children. As I told you, this question was asked for 4 marks. How actually the marks were distributed over here? First of all, saying that x minus a equal to 0, then x equal to a, by factor theorem, getting the expression f of a is equal to 0. This will give you 1 mark. Correct substitution itself will give you 1 mark. Later a cube is equal to 27. Then finding the value of a, that will fetch you 1 mark. See, this is how actually the marks are distributed. See, children, so simple question you are asked to find out for 4 marks, right? So what does it mean? Scoring marks in the board exam is not at all a big task. It is just a cakewalk, right? So if you understand the question correctly, analyze it properly, you can just solve the question very easily. Now let me take one more example over here. The example is from the 2025 specimen paper, that is for the upcoming exam, right? So the question is, while factorizing a given polynomial using remainder theorem and factor theorem, a student finds 2x plus 1 is a factor of the expression 2x cube plus 7x square plus 2x minus 3. Is the student's solution correct, stating that x plus 1 is a factor of the given polynomial? Give valid reason for your answer and also factorize the given expression completely. So now the child is telling that the given polynomial has 2x plus 1 as a factor. So let me write the polynomial over here. F of x is equal to 2x cube plus of 7x square plus of 2x minus 3. Now here we don't know whether it's a factor or not, but child is assuming that it is a factor. So I'll just take it as a divisor over here, because we don't know actually it's a factor or not. That means the student is right or not. Okay, divisor is 2x plus 1. So divisor to be equated to 0. 2x plus 1 is equal to 0. That is equal to x is equal to 1 by 2. Minus of 1 by 2 I get. So now I am supposed to find out by remainder theorem. By remainder theorem. What is the remainder over here? Remainder is going to be f of minus 1 by 2. If I am finding f of minus 1 by 2, if I am getting it as a 0, means what? If I am getting remainder as a 0, I can say 2x plus 1 is a factor of the given polynomial. That means student is right. If I am not getting it as 0, that means what? 2x plus 1 is not factor of f of x. That means the student is wrong. Let me find out f of minus 1 by 2. So in the sense, wherever x is there, you are replacing it by minus 1 by 2. Now let me go ahead with that. 2 into minus 1 by 2 whole cube plus of 7 into minus 1 by 2 the whole square plus of 2 into minus 1 by 2 minus of 3. Right, I'm just substituting wherever x is there, I'm substituting that by minus 1 by 2. So later what I get over here is 2 into minus 1 by 8, I'm getting it children, plus of 7 into 1 by 4, because minus into minus is plus. Then I'll get, see if I cancel this, 2 ones are over here, plus into minus is minus 1, can be written directly, and minus 3. Here also I can cancel this one children, 2 ones are, 2 fours are. Right, so minus 1 by 4 plus of 7 by 4 minus 4 directly can be written by 1, minus 4 by 1. So LCM is going to be 4 itself. So I can write minus 1 plus 7 minus of 16. I hope so why it is 16. Okay, you understood why it is 16 into 4 and into 4 over here. So what I'm going to get here children, minus 1 plus 7 minus 16, that is nothing but minus 17 plus 10, that is minus 10 by 4, that is equal to minus 5 by 2. So which is not equal to 0. So I am not getting the remainder as 0. So what can I conclude children then? My conclusion is, since remainder is not 0, remainder is not equal to 0, that implies 2x plus 1 is not a factor of given polynomial f of x by factor theorem. So by factor theorem, I have concluded that 2x plus 1 is not a factor of f of x. So now I have given a valid reason why it is not a factor. My next task is to factorize the given expression completely. I need to factorize this expression completely. For that, I will write down the given expression, that is 2x cube plus 7x square. Pay attention children. Okay, f of x is equal to 2x cube plus of 7x square, then plus 2x minus 3 plus 2x minus 3. So whenever I'm going to factorize this expression completely, as I told you earlier, make sure that the powers of the variables are arranged in descending order. Powers of the variables are arranged in descending order. Then later take the factor, all possible factors of the constant term 3. So all the possible factors are plus or minus 1 or plus or minus 3, because 3 is a prime number. By hit and trial method, I find out f of 1, f of minus 1, f of 3, f of minus 3. So for any one of the values, it will be 0. Okay, all that steps need not be shown over here. Only for what value of x you are going to get 0 over here, only that value should be shown over here. So here f of minus 1 I will try. So if I am going to try with f of minus 1, 2 into minus 1 the whole cube plus of 7 into minus 1 whole square plus of 2 into minus 1 minus 3. So here I am going to get it as minus 2 plus 7 minus 2 minus 3. Right. So here if you observe it carefully, I am going to get it as 0. So since I am getting the remainder as 0, so this is nothing but remainder over here. This is nothing but remainder over here. I can say it works when x is equal to minus 2. So means what? When I take this minus 2 is this side, x plus 1 is equal to 0. See, since the given polynomial is cubic polynomial. Why I am saying it is cubic polynomial? Because degree of the polynomial is 3. Degree of the polynomial is 3. So it is a cubic polynomial. So for every cubic polynomial, I must have 3 factors. I must have 3 factors. So since the question is factorize it completely, so means what? I need to find out all the 3 factors. Out of all the 3 factors, I have found out the first factor, that is x plus 1, right? So I can say that implies by factor theorem, by factor theorem, I can say that x plus 1 is a factor, okay, a factor of f of x. So now remaining two factors to be found out. So how I am going to find out the remaining two factors? For that I am going to perform long division method. Children, pay attention. So now I'll take the dividend, that is 2x cube plus of 7x square plus of 2x minus 3 to be divided by the first factor, that is x plus 1, to be divided by the first factor, that is x plus 1. This division can also be done by the synthetic division also, children. Synthetic division is also accepted in the board, doesn't matter, okay, right. So now I repeat the same process. Take the first term of the dividend divided by the first term of the divisor. I'm going to get it as 2x square, that is going to be the first term of the quotient. So 2x square into x is 2x cube. 2x square plus 1 is 2x square itself. So I'm supposed to change the sign, right. So here this will get cancelled. I'm going to get 5x square plus of 2x. Why plus 2x? Because this 2x to be taken down. Again repeat the same process. First term of the dividend to be divided by the first term of the divisor. I'm going to get it as 5x, which is nothing but the next term of the quotient, 5x. So 5x into x is 5x square. 5x into 1 is plus of 5x. So change the sign over here, minus, these two will get cancelled. Here I am going to get it as minus 3x. Then this minus 3 to be taken down. So again repeat the same process. Minus 3x divided by x, that is first term of the dividend, divided by first term of the quotient. I am going to get as minus 3, that is nothing but the next term of the quotient. Minus 3x minus 3, that is after changing the sign, I am going to get it as 0. Obviously it should be 0. The remainder should be 0, which I have shown it earlier over here, okay, which is already shown it over here, right. So now I have found out the other factor of f of x. So I can write down f of x is equal to the product of factors, right. So that is nothing but x plus 1 and 2x square plus of 5x minus 3, right. So when I multiply these two, I am going to get the given polynomial f of x. So as I told you, children, again, since the given polynomial is cubic polynomial, it should have three factors. But again, I have got two factors over here. The second factor, if you observe, it is a quadratic polynomial. So there are two factors for a given quadratic polynomial. So how should I do it? Factorize the given quadratic polynomial over here, whatever I have obtained. So split it and factorize it. So 2x square I do, plus of 6x minus of x minus 3. This is how I can split it. You have learned how to factorize it in your 9th standard and 8th standard, right. So here I would like to grab your attention. Whenever you are splitting it and factorizing it, whenever you are making two signs as three signs, if there are minus signs, there should be two minus signs, otherwise no minus sign. Means what? If you are getting one minus sign or three minus signs over here, that means your splitting is wrong. So be very careful about it. So now I'm just writing this one as x plus 1. Over here I group these two. I'll take out 2x common, then x plus 3 minus 1 x plus 3 I'm going to write. So that is equal to x plus 1, then x plus 3, then 2x minus 1. These are the factors of given polynomial f of x. These are the factors of given polynomial f of x. Be very careful about this, children. These are the given factors of given polynomial. What are the factors? I can say the factors of polynomial are x plus 1, x plus 3, then x 2x minus 1. These are the factors of the given polynomial, right. So if you do like this, there are no chances of deducting the marks at all. So how the marks are distributed over here, right. So you have arrived at the answer. How actually distribution of the marks happens, I'll explain about that. So since the question was for 4 marks, First of all, to find out whether 2x plus 1 is a factor of given polynomial or not, and concluding it, that itself will give you 1 mark. In the sense, so over here you have found out minus 5 by 2, it is not a factor, you have decided it is not a factor, right, giving a proper reason, right, you will get 1 mark over here, 1 mark over here. So later, identifying the other factor, which is the actual factor, and identifying all the 3 factors correctly, that will give you 1 mark. If you do like this, children, there is no chance of deducting the marks at all, right? So I hope so that today's video is very fruitful, right? Please keep studying for some more videos like this. Please subscribe my channel, keep watching my channel, and like the videos in my channel, that is Ignite Math ARP. So children, see you with the next video. Till then, take care, keep working. Bye bye.